In this video, I will explain find the Fourier transform. Fourier transform of the following signal shown below. This one is sub t. T 0 -2 -4 -6 -8 -10. In -10 and -6 -8 0 2 4 6 8 and 10. Yeah, 6 and 10. This will be the values. Find the Fourier transform of the following signal shown by the example. Now, solution. How to consider one signal, same shape. Some limits are different. Limits, suppose we have to take -2, 2 + 2, some triangular waveform here, and perform some shifting operations, and then add these resultant signals. We will get the original example. Consider one function. One function that is g of t. Let it be g of t. The intervals limits from -2 to 2. This is the function. This is the function g of t. Same shape. -2 to +2. We have to perform some shifting operations. Suppose here g of t minus k. G of t minus k. That is equal to t minus k is equal to t is equal to k. It is here 1. Amplitude is 1. -2 to +k. 2 to +k. Here -2 + k is equal to 6. Is equal to not 8, equal to 6. Equal to 6. For k is equal to 6 + 2, that is equal to 8. K is equal to 8. Okay. 2 + k is equal to 10. 2 + k is equal to 10. K is equal to 10 minus, that is equal to k is equal to 8. K is equal to 8. Therefore, the value of k is substituted here. K value is substituted here. G of t minus k value is 8. G of t minus 8. Here 8 minus 2, that is 6. 8 + 2, that is 10. This is the function g of t minus 8. We will get this one. Now I will concentration on this one. Again consider g of 8. G of 8, again consider g of 8 minus 2 to 2 t 1 g of t g of t plus k. G of t plus k here minus t plus k means t is equal to minus k minus 2 to minus k 2 minus k. The function is 1 minus 2 minus k 2 minus k. Minus 2 minus k is equal to minus 10. Minus 2 minus k is equal to minus 10. Minus k is equal to minus 10 plus 2, that is equal to minus 8. And similarly, 2 minus k is equal to 2 minus k is equal to minus 6. 2 minus k is equal to minus 6. Minus k minus 6 minus 2. Here minus k is equal to minus 8, k is equal to 8. Here minus k is equal to minus 6 minus 2, that is minus 8. K is equal to 8. Therefore, the function is minus 2 minus 8, 2 minus 8. G of t, k value is 8. K value is 8. Therefore, minus 2 minus 8, that is minus 10. 2 minus 8. 2 minus 8 is minus 6. Here, amplitude is 1. Okay. G of t. First one is g of t minus 8 function is g of t minus 8 function is. We know that g of t minus 8 function is 6 comma 10. 1. This is the 6, 10, 1. G of t plus 8 is equal to g of t plus 8 is equal to some minus 10 minus 6. This one is minus 10. Minus 10 minus 6. Which is g of t plus 8. This one is g of t minus 6. Now x of t is equal to g of t plus 8 plus g of t minus 6. Consider this one. X of t is equal to g of t plus 8 and g of t minus 8. G of t plus 8 is minus 10 minus 6. That is here minus 10 minus 6. Minus 10 minus 6. And g of t plus 8 is here 6 comma 10. The function here is 1. X of t is equal to g of t plus 8 and g of t minus 8. Here minus 6 minus 8, here 6 8. Apply. Therefore, finally, x of t is equal to g of t plus 8 and g of t minus 8. X of t is equal to x of t is equal to g of t plus 8 plus g of t minus 1. Apply Fourier transform. Fourier transform of x of t and Fourier transform of g of t plus 8 and Fourier transform of g of t minus 8. Fourier transform of x of t is x of omega is equal to Fourier transform shifting function. Fourier transform of g of t plus 8 is e power shifting e power plus j 8 omega e power plus j 8 omega into g of omega plus e power minus j e power minus j shifted value is 8 omega into g of omega. We know that g of t value is g of t function is -2 plus 2 1. This is g of t. Initially, I have selected some arbitrary signal. Consider one function -2 to 1 g of t. Apply Fourier transform. Here apply Fourier transform to this function. Here coordinates are -2, 0. From this point to this point, -2. Here 2, 0. Here the coordinate is 0, 8. Consider -2, 0, 0, 1, x1 by 1, x2 by 2, y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Y minus 0, y2 is 1 minus, y1 is 0, x2 is 0, minus 2, x minus x1 is plus 2. Therefore, y is equal to 1 by 2, x plus 2. Y is g of t, x is t. Find out the slope. Slope means dgt of t by dt is equal to 1 by 2. 1 by 2. And similarly, 2, 0, 0, 1, 2, 0. x1, y1, x2, y2, y minus y1, that is 1, y2 minus y1 by x2 minus x1 by x minus 0. Y minus 1 is equal to -1 by 2x. Y is e of t, x is t plus 1. dg of t by dt, t is equal to -1 by 2. Therefore, this one is the g of t, t -2 to this is 1. Okay, differentiation of this function is d g of t by dt. Slope is first in that interval -2, 0 in that interval. The slope is the slope is 1 by 2. The slope is 1 by 2. In the 0 to 2, the slope is -1 by 2. The slope is minus by 2. Again, perform d square g of t by dt square. This one is time axis, this one is time axis. D square g of t by dt square. Here rising function. Here -2. -2 differentiation is a rising function from -0 to -0 to some 1/2. That is 1/2. Here falling function here. Constant differentiation is 0. Constant differentiation is 0. -1, 1/2 of -1/2 plus 1, 1/2 plus 1/2, 1. This is the 1 at t equal to 0. Again, come to this side. Constant differentiation is 0. Here, rising function. 0 of 0 minus of -1/2 plus 1/2. That is at 2. At 2, the value is 1/2. Therefore, d square gt by dt square is equal to, convert this into function, convert this in form, mathematical form, dou of t plus 2 into 1/2. This one is -1 minus 1 into dou of t plus 1/2 into dou of t. Left shifted impulse function and right shifted impulse function. Apply Fourier transform. Fourier transform of d square g of t by dt square. Fourier transform of entire function 1/2 dou of t plus 2. Left shifted impulse function minus dou of t plus right shifted impulse function. Fourier transform is here. Second derivative j omega whole square g of omega. Fourier transform. This is the shifted function 1/2 e power j, shifted value is 2 e power j to omega minus Fourier transform of impulse function is 1/2 e power minus j to omega, and then Fourier transform of t is again 1. That is equal to e power j to omega plus e power minus j to omega by 2 minus 1. J square is minus omega square. J square is -1 minus omega square g of omega minus omega square g of omega is equal to cos 2 omega minus 1. G of omega is equal to minus, here minus sign is there. That is 1 minus cos 2 omega by omega square. 1 minus cos 2 omega is 1 minus 2 sin square. Cos 2 x is equal to 1 minus 2 sin square x. It is omega square. Minus 1 cancel. Plus 1 minus 1 cancel. Minus into minus plus 2 sin square omega by omega square. This is g of omega. We know that x of t is equal to g of t plus 8 g of t minus 8. Fourier transform, apply Fourier transform. X of t is x of omega, original function. Here this is the shifted function. This is the shifted function. G of t plus 8 is e power j omega 8, and Fourier transform g of t is g of omega. Here e power minus j omega 8. Fourier transform g of t. Fourier transform g of t is g of omega. Substitute g of omega in that expression. E power k 8 omega into g of omega is 2 sine square omega pi omega square. C power minus a 8 omega. G of omega is equal to 2 sine square omega by omega. The common term is 2 sine square omega by omega square e power j8 omega plus e power minus j8 omega. E power jx plus e power minus jx. Numerator and denominator multiplied with 2. That is equal to 4 sine square omega by omega square. E power j8 omega plus e power minus j8 omega by 2 is cos 8. This is total function Fourier transform. With this, the total analysis is completed. If you like this video, please subscribe the channel for further updates.